Hello and welcome back to Solving Systems Using Substitution. We are going to do examples 6 and 7, which are 3x3 systems. These are a little bit more challenging. So I'm not looking for the variable that's by itself because I have 3 separate equations. I want to find the simplest possible equation. That's my first step. Simplest possible equation. So what do we mean by simple? Okay, well, it could mean small numbers, so small coefficients. That's one way of doing simple. But another way of doing simple, and this is the key, is the fewest variables. Okay, so I'm looking for an equation that only has 2 or 1, not all 3, just 2 or 1. So on example 6, top equation has all 3. I'm not going to use it. Second equation only has 2. That's a winner. Okay, so I'm going to start with my second equation. So I want to use this piece. Now, because there's 3 equations, it's a little hard to keep track of, I'm going to label them A, B, and C. So I have A, B, and C. And now I'm going to tell you that I'm going to use the first equation, A, and the second equation, B. Alright? So we're going to use A and B. And specifically what we're going to do is we're going to plug B into A. Now what does B equal? What does it have? It has the Z. So wherever I see a Z, I'm plugging that expression in. So I'm going to write the rest of it. The rest of equation A, I have negative x minus y minus 3, and now here's my Z equals negative 9. Okay? So that is where I'm plugging in the Z. And what goes in those parentheses? Negative 3x minus 1. Now we're just playing the simplify game. Not a big deal. We're going to distribute that negative 3, and we will combine some like terms. Okay? So we have negative x minus y plus 9x plus 3 equals negative 9. Easy enough. Not a big deal. Okay, so now we do have to combine like terms. So 9x minus x gives me 8x minus y plus 3 equals negative 9. Now I see that that y has a coefficient of negative 1. So I'm going to solve for that y because now I can have 2 expressions where I just have 2 variables. And that's going to help me simplify, okay? So I'm going to move everything to the other side, all right? So we are going to subtract the 8x and subtract the 3. All right? So I get negative y equals negative 8x minus 12. Okay? Well, when we divide by that negative 1, guess what happens? Plus, plus, plus. Now here's the cool part. Look at that. Now I have y by itself, and I have an expression for y that I can plug into something else. So what's the only equation I haven't used yet? C. So let's start with C. And in C, we're going to plug in the y, and we're going to plug in the z. Okay, so we're going to get rid of both y and z, and this is going to be really super cool. Okay, so equation C, I have x equals 5, and there's a y. So I put parentheses. Minus z, getting rid of it, put parentheses, plus 23. Okay? Now what was my expression for y? Well, we just found that. That was the 8x plus 12. And what was my expression for z? That's the one we started with. Negative 3x minus 1. Now, I want you to look closely at that equation. Do you see, how many variables do you see? 1, 2, 3 variables. Are they all the same? Are they different? They're all the same. That's the goal. That is the goal. I have an x, an x, and an x. That means I can distribute and I can solve for x. And once I get x, I can plug it back in and find the others, okay? So let's do that. We're going to distribute the 5, and we're going to distribute the negative, And we're going to combine some like terms. So I have x equals, that becomes 40x plus 60 plus 3x plus 1 plus 23. Okay? Let's combine like terms. So x equals 40 plus 3 is 43x. 60 and 24 is 84. Okay, we're close. We're super close, right? Super, super close. What do we need to do? We got to move the 43 to the other side. So end up with negative 42x equals 84. Now divide by negative 42. I get x equals negative 2. That is not my final answer. It's only part of it. I still need y and z. Okay? So let's look at y here. Okay? So y was equal to 8 times x plus 12. Right? What was z? Z was equal to negative 3 times x minus 1. All right, well that's cool. Now we can plug that in. So I'm plugging in negative 2 to both places. All right? So z equals, that becomes 6 minus 1, which is 5. Y is equal to negative 16 plus 12. That's negative 4. So my final answer is negative 2, negative 4, 5. We do put them in alphabetical order, so it's X, Y, Z, just like the alphabet. Okay? That's how you solve 3 by 3 systems. You would actually do the same thing if I had 4 equations and 4 variables. And yes, 5 equations and 5 variables. And yes, we do have situations where we do that. Okay? So an example, you live in a 3-dimensional world, right? You have a length, you have a width, you have a height, you are 3D, okay? So when I worked on the International Space Station, we had a system of equations, and we had an X direction, a Y direction, and a Z direction. And those 3 variables together in the equations told us where the space station was at as it was orbiting the Earth, which is kind of cool, okay? We didn't solve those by hand. Okay, we had the equations because we knew what the orbital pattern was. But this is how we did it. We established it, okay, knowing the equations and knowing the physics. All right, let's go ahead and do, before I get off on tangents, all right? Let's go ahead and do example 7. So let's look at our equations. All right, I see the first one only has 2 variables. So I can use that one. The second one has 3 variables. Not going to use that one. The third one also only has 2 variables. I wonder which one I should use. Well, the first one's already solved for x, so that's really cool. So we can just go ahead and put that in parentheses. Let's go ahead and solve that third one. All right, so if we're doing A, B, and C again, because we love A, B, and C. So I'm going to work with equation C. I'm going to solve that for the Z component. Why am I picking Z and not Y? Why? Because I don't like it. No. Because Z has the 1 in front. I don't have to divide. I'm not going to end up with fractions. So I know how much you guys love fractions. Okay? But we're going to take that negative 5y and we're going to add it to the other side. So we get 5y plus 25, and then when we divide by that negative 1, you get negative 5y minus 25. Okay? So now I have 2 equations. That I can plug in. So let's take equation B. That's the one we haven't really used and we haven't touched, right? We're going to write it out. We're going to put parentheses. Everywhere there's an X, everywhere there's a Z. Okay, so I have Y equals 5. There's an X, parentheses. okay? Plus z, parentheses, minus 4. All right? So now what am I plugging in for x? For x, we're plugging in minus 4z minus 19. Okay? What are we going to plug in for z? For z, minus 5y minus 25. All right? So now look, I still end up with a z in here instead of a y. We need to do something to get rid of that. Well, let's hold off on using equation C. We'll come back to it. We're going to plug something different in there. I want to use this x, and I'm going to take z, and I'll plug it in here. Because I noticed the z has a y in it, and this has a y in it. So let's get rid of the z over here by putting a y in it, all right? So we're going to have x equals negative 4, parentheses, minus 19. And in there, we're plugging in our z value. Okay? So our z was minus 5y minus 25. Okay? We still have to distribute that wonderful 4. So we have x equals, that becomes 20y plus 100, 4 quarters makes $1, minus 19, not a big deal. So that's 20y, and this becomes 81, right? 20y and an 81. Now, x is by itself, still, and on the other side, I have y's. Okay, that is beautiful. So I have 20y plus 81. So I have a y, and a y. Do I have any x's? Nope. Do I have any z's? Nope. Oh, wrong color. We'll just do it with this one. Okay, so we plugged in z, we plugged in x. Now we can actually distribute and solve for y. Okay, so I have y equals, remember we're distributing that 5. 5 times 20. It's actually 100. Okay, 5 times 81. It's 405. It's okay if you get your calculator out. Then we have minus 5y minus 25 minus 4. Easy? Well, yeah. Okay, so now let's combine like terms. So I still have my y on the other side. 100 minus 5 is 95. Then I have 405 minus 25 minus 4. It's actually 376. Now I'm going to move that y to the other side. So I'm going to have negative 94y equals 376. Now I've got to divide by that negative 94. The cool part is it is a whole number. It's actually negative 4. Okay? This is 1/3 of my answer, right? And now I have to take that y, plug it back in for x, and plug it in for z. So let's do the x first. Okay, so we have x equals 20 times that y plus 81. And then for z, lots of arrows in here. I'm just going to write it over here to the side. Negative 5 times that y minus 25. Okay, so what was y? Y is negative 4. So again, negative 4, negative 4. Okay, so x equals 20 times negative 4 is negative 80. Negative 80 plus 81 is 1. Look at that. All big numbers one way. Okay? So that's my x. Now let's do z. Negative 5 times negative 4 is 20. 20 minus 25, that's negative 5. So my answer, remember write the x first, is 1, -4, -5. Now, you may be saying, well, we're getting negative numbers. If you were on space station, you would get negative. Remember, there's a positive x-axis and a negative x-axis. Negatives in real life don't always mean a loss or doesn't mean below ground. It means direction. So it can mean to the right or to the left. In our last segment of notes, we will actually do the word problem where we'll write our equations, 3 equations, 3 variables, and we will solve it. Welcome back. This is Mrs. Boots. We're still solving systems with substitution. We're going to do our last example, which is a word problem. So we're going to read through and write our equations. I should let you know that most word problems, each sentence typically forms its own equation. So when you see a period, that's the end. So read just one sentence at a time and see if you can make sense of it that way. That's a good starting point if you struggle with word problems, okay? So in example 8, we're with Sam at an arcade. And Sam won 2 blue tickets, 1 yellow ticket, and 3 red tickets for a total of 1,500 points. So I'm given a total. That means I need to add those 3 things together. So I have 2 blue plus 1 yellow plus 3 red, and that's going to equal to 1,500. Okay? That's my first equation. All right? Now let's look. James won what? He has 1 blue ticket, 2 yellow, and 2 reds. So blue, 2 yellow, 2 reds. And his total was $12.25. All right? Now we have Jessica. Jessica has 2 blue, 3 yellow, and 1 red. Okay? So 2 blue, 3 yellow, and 1 red. And that's 1,200 points. Now, based on what I told you before, these are kind of crazy, right? Because all of them have all 3 variables. So we wouldn't use any of them. I would actually use elimination on this problem and not substitution. But I wanted to pick a super hard problem so that you could see how it would work. Okay? So we have our A, our B, and our C. Maybe I shouldn't use B. Equation 1, equation 2, equation 3. All right? So if I look at equation 1, I could solve that for y. Right? We could do y on that one. Equation 2, yep, the b doesn't have a coefficient. In equation 3, we would pick the r. All right? So it depends on which one you want to start with. What do you want to start with? I'm going to start with equation 2. I'm going to get that b by itself. All right? And I'm going to plug it into the other 2 equations to get rid of all my b's. Okay? And then we'll go from there. All right? So I'm going to start with equation 2. Let's get b by itself. So to get b by itself, it's super easy. All we have to do is subtract the other 2 things. So now I have 2y minus 2y minus 2r plus 1225. All right? That's my b equation. Okay, so now I'm going to take equation 1 and equation 3 and plug in and see if we can get rid of that b. Okay? So let's start with equation 1. So we're going to come over here. So I have 2, big set of parentheses, plus y, plus 3r equals 1,500. Okay? What goes inside the parentheses is the b. Okay, so I have minus 2y minus 2r plus 1225. Okay, now you could have started with equation 3. That's okay. You don't have to start with equation 1. I just chose to start with equation 1. All right, we're going to come in and distribute that 2. Everybody's going to get the 2 that's inside the parentheses. So now I have negative 4y minus 4r plus, what do we get for that? 2450 plus y plus 3r equals 1500. All right, so now let's combine like terms. So I got y's and I got r's, right? So that gives me negative 3y minus r equals 2. Oh, got to move that 2450 to the other side. What are we going to get? Negative 950. Here's another equation where I could solve for r. Only this one only has 2 variables, okay? So let's go ahead and do that. Let's go ahead and get that r by itself. So I would add the 3y to the other side, and then divide by negative 1. So I get r equals negative 3y plus 950. Okay? So now I have an r. So we started off with a b. We have an expression for b. We have an expression for r. Where should we go next? Well, we haven't used equation 3, right? So let's come down and actually use equation 3. What can I plug into equation 3? Well, I know what b is, and I know what r is, right? Let's just plug in the b. Let's just plug in b and see what we get. So equation 3. I have 2, got my b, plus 3y plus r equals 1200. So I get the feeling this is going to simplify. What was b again? Minus 2y minus 2r minus, plus 1225. Okay? So we're plugging b into both equation 1 and equation 3. This is why I told you I'd use a different method if I did it. But I want you to see how crazy it can get. Okay, so we still got to multiply everything by 2. So we get negative 4y minus 4r plus the 2450 plus 3y plus r equals 1200. Now when we combine like terms, I have y, negative y minus 3r equals what? Well, that was 1250, right? So it means negative 1250. Okay? So I'm going to move the r to the other side. Do I want to move the r to the other side? I could just multiply everything by negative 1. That makes everything positive. But don't we know what r is? Yeah. Looky there. We know what r is. So I can plug in for my r. Let's go ahead and do that, because then we can solve for y. Right? So I have y plus 3 times negative 3y plus 950 equals to 1250. It's kind of crazy, but we could do it. Or we could solve this for y and plug it into here for r. Either way. Okay? We can do it either way. Okay. So now what are we going to get? I get y minus 9y. 3 times 950. It's 2850. Equals to 1250. This is crazy. Well, that gives me a negative 8y. And when I move 2850 over to the other side, what am I going to get? So 2850 minus 1250 gives me 1600. Well, hold on. That's divisible by 8. So y is negative 200. I did something wrong. There's a negative sign right there, right? Yep, so that's a positive 200. Can't have a negative amount of points. That was my first clue. So y is 200. Now I can plug y in here and find r. So it's negative 3 times that plus 950. So we have our y value, 200. Right? Okay, so r equals, that's negative 600 plus 950. So what's r? Yep, 350. Okay, so I have 200 points for yellow, 350 for red. Now I just got to find blue. Well, we got the equation for blue right here, right? So my blue is going to equal to negative 2 times yellow. 200 minus 2 times red plus the 1225, right? So let's plug those values in. So my yellow was 200. My red was 350. Okay? So I have negative 400 minus 700 plus 1225. This is 1100, right? So B is 125. So I have 125 points for the blue, 200 points for the yellow, and 350 points for the red. Now I would have actually used elimination to solve this, or matrices. Elimination is in our next lesson, and matrices is in the next unit. And so we will go forward and explain those another time. I hope this has helped. Please go ahead and begin your practice.